First of all, I'd like to welcome you all. So my name is Kenneth Wong, the professor in the Faculty of Engineering. I'm also the chairman for Engineering Admission Committee. So again, that's welcome you all. So even though it's virtually, that's thanks for joining us today. That's a very unique situation. I think you can say once in a lifetime situation that we have these kind of information section virtually being conducted this year. So I hope that it's very inconvenient, but I think that's also the lesson that's as an engineer, this is exactly the lesson that we can show how engineering will perform these days. Okay, so again, welcome you all. I know that we still have students in the waiting room, so I hope that you will be a bit very soon. Okay, so but for those already joining us, so just to make sure again that's about the logistic. Okay, so make sure that that you're clearly heard, and so that's any hiccup and all those things. Okay, so now we're going to start our virtual information section today for the JUPAS 2020 applicant. Okay, so today we have a great honor that we have a series of speakers. But before that, now we'd like to welcome our Dean of Engineering, Professor Christopher Chow, to say a few words to welcome you all. So let's pass the time to Professor Chow.
Thank you very much, Kenneth. It is my great honor to be here today to greet all of you to join this event organized by Faculty of Engineering at the University of Hong Kong. I'm sure that you are interested in knowing more about our programs and also to know more about what engineers can do. In fact, the Faculty of Engineering at Hong Kong U has been going through a lot of very exciting events recently. Our 10-wing fund innovation wing will be open very soon, which will provide a very large facility and space for our students to do project-based learning activities and also to do experiential learning activities because of a very generous donation of $100 million from one of our alumni. And all of you, if you join Hong Kong U, you will be having a chance to use the facility. And it is one of the largest makerspace area in Asia, if not in the world. And last week, you probably read from social media and newspaper that we also received a $60 million donation from Standard Chartered Foundation to build a FinTech Academy at Hong Kong U, hosted by engineering through our computer science department. So for those who are interested in joining our BASC FinTech program, I'm sure that many of you will be benefiting from this major gift. And you will be exposed to a lot of FinTech related activities. And also some of you will be receiving scholarship from the academy as well. So as Kenneth mentioned to you earlier, we are going to have a number of speakers. The first one, Professor Hayden from our EEE department will be telling you more about the role of engineers. And then we will have our Associate Dean of Engineering in charge of teaching and learning, Professor Edmund also from EEE department, telling you more about Faculty of Engineering and some information related to our different programs. And then our Professor Thomas from Civil Engineering, also our Associate Dean in charge of Student Development. He will tell you more about the 10-wing fund innovation wing that I mentioned to you earlier. And at the end, we will be having a Q&A section chaired by our MC, Professor Kenneth Wong again. So without further ado, I think I have to let our speakers to tell you more about what they are doing. Thank you.
Hello, good afternoon. I guess I won't block the slides too much. Good afternoon, and again, welcome to our engineering info sessions this year, very especially online. And want to welcome all of you watching it online right now. And it's going to be recorded, so for those of you in the future watching it back, welcome again. My name is Hayden So. I'm from the EEE department. My expertise is in computer system design, and I look at the computer engineering program. But today, I think I'm going to share with you some of the thoughts that are just generally about engineering that I have been collecting myself over many years on this age-old question on what is engineering. So I think I asked this question myself maybe around your age when I was trying to get into university and trying to think of a good major to go into. And I started asking this question, what is engineering? What's so special about it? What's the difference between this and science? And frankly, at that time when I was young, I have no idea what engineering is about. And then I find myself still thinking about this question all through my career, through my PhD, now working at university and teaching students. And I'm still asking this question, and I urge you to follow my journey on trying to figure out what engineering is all about. And one thing I noticed though is depending on who you ask, you might get very different answers on what engineering is about. So today what I'm going to do is to share with you my side of the story. I hope by the end of all this, you come to the same conclusion as I did many years ago, that engineering is really fun. And to many surprise, I think engineers are some of the smartest and funniest people to hang out with. So let's see how it goes. So let's start with this hypothetical scenario. So this is 2 a.m. in the morning, it's dark and quiet, you're sound asleep, you're enjoying, you have just a long day, but then you start smelling something funny. You went out and you saw a fire in the kitchen, and you find that the recycle bin is on fire. So what do? What are you going to do? Okay, so no one, you might have all your answer. I cannot see your reaction, so I don't know what your answer is. But at least according to some ancient internet jokes from the 1990s, that's what would have happened. If you're a mathematicians, wake up, the mathematicians saw the fire, and then he proved to himself that there exists a solution that I can put this fire away. All right? And then that being a mathematician is happy, he got the proof, and he went back to sleep. At the end, fire is still burning. Then came in a scientist, the scientist came in, the scientist also saw the fire, and then he started making hypotheses and say, hey, you know what? I know I can put out the fire with water. And then he starts studying the thermodynamics. He starts studying the component, whatever is in the recycle bin. Is it combustible or not? And then he started to derive mathematically the optimal amount of water that might be needed to put out that fire. And he also designed experiment and tried to test the hypothesis to find the optimal amount of water. Maybe it's just a small cup, 20 milliliter of water. That's probably enough to put out that small little fire of the recycle bin. And finally, he's very happy because he now has his control experiment where there's no water and see if the fire will continue to burn, and he went back to sleep. So at the end, fire is still burning. Finally, the engineer came in. She's tired, she has a long day. She went out and saw the fire. Without second thought, she went in, get a big bucket of water, pour it on the water, onto the fire, put it out, and went back to sleep. All right? So that's how the internet jokes from the 1990s was like. I don't know if you are laughing because I cannot see your face. But one thing that is interesting about this joke is that when you compare and look at how mathematicians, physicists, and engineers approach problem, you'll find that they approach problem very differently. One thing that is very right about this joke is that engineers, to me, are the problem solvers. That's one key trait of what engineers do, right? Of course, by no means I say, I'm definitely not saying that math is not important and science is not important, it's all about engineering. Just the opposite, science and math are extremely important. They form the foundations on how engineers work. So if you ask me over the years, what I've seen is that engineering to me is nothing more than just a process. On one hand, engineers get the problem, and then on the other hand, hand out a solution. But we don't give out just random solutions. Good engineers actually build the solutions with solid math and science foundations. And we make use of the latest technologies. In fact, we build our new technologies, and we do it systematically. We do it professionally. That's why engineers are professionals. With that foundations, we do scientific research. We figure out what's the good solutions, and then we combine them with our experience, maybe our code of conduct, maybe even just our gut feeling. And more often than not, you still need a little splash of ingenuity put into your solutions. And at the end, we solve the problem. And that's basically what I think engineering is about. Engineering is a verb to me. It is an action. It's a process of solving problems, taking problem and getting to the solutions. So if this is still very abstract to you, maybe I should just go through an example and see some of the classic examples of what I think of good engineers are doing. A classic example that you may often find in different textbooks concerned about this Apollo 13 mission. So for those of you who are a little bit too young to see it, it was a lunar mission from the NASA in the 1970s. So it was Apollo 13, so it was already the third time that NASA was sending people from Earth to Moon. So the original plan was that they will go from Earth. They already been to Moon 2 times, and this will be the third time they went all the way to Moon. They will land on the Moon and do the experiment. However, something happened. What happened is by day 3 into the journey, the oxygen tank number 2 exploded in the service modules. All right, so that was day 3. What it means is that the modules, the 3 astronauts, was just in the middle of their journeys going to Moon. Literally, they are in the middle of nowhere. They are somewhere between Earth and Moon. They have no help. There are only 3 persons on board. But then because of the explosions, you're already getting loss of power, you're getting loss of oxygen, all the life-supporting mechanisms are falling apart. So you need to find solution quick. Otherwise, you end up with a space junk with 3 cops inside going to Moon. Okay? The story goes is that at the end, of course, is a happy ending. They came back. They actually arrived at the Moon, Apollo 13. They did not land on it, of course, because the module is already broken due to the explosions. But they managed to bring the 3 astronauts back to Earth on day 6. Right? So this is a wonderful story to tell, and this will be a good example for us to learn what is good engineering. So what was so right that they have done to bring people from an explosion in day 3 through 4 days of ordeal, round the Moon, and came back to Earth safe in 4 days. So this is a wonderful story to tell, and let's see what happened. Of course, during the 4 days of the journey, there are multiple problems. I'm just showing you one of them. One of the classic examples here is colloquially known as the square peg in the round hole problem. So one of the problems the astronaut had at that time was that they were hiding in the lunar modules, but the CO2, the carbon dioxide level there is already rising at a toxic level. In other words, if you do nothing else, they are going to run out of oxygen and they will start get poisoned by CO2. So it's a major problem, pressing problem. One possible solution is that on board, they do have these special lithium hydroxide canister for CO2 scrubbing. So they have these canister, when you blow air through it, they will actually take the CO2 out of it and reduce the level of it. All right? So it's a possible solution, except that they are hiding in the lunar modules. In the lunar modules, the CO2 canisters receptacle is round shaped. But what they have on board is the canister from the command modules that is square. So now the actual problem is you have these square-shaped canisters. You want to use them to save the astronaut life. How do you put this square canister into this circular hole? How? Right? And remember, all through this, you're stuck in space. You really don't have any spare parts. You are already on the spaceship. And there are no proper tools. You cannot really cut the corner. You can't do anything with it. What can you do? So if you read up on the stories, at the end, they managed to create something ingenious. And that's what they came up with. This is what they came up with at the end. It's a makeshift connector to the square-shaped canister, so it will actually connect into the round hole. Specifically, what happened is that taking the canisters here, the astronaut took all the parts that they can find on the spaceship, in this case, just a random plastic bag from a food storage, a cardboard from one of the flight manual cover, so it's usually a hardcover, a lot of duct tape for taping things together, and finally, the hose from the spacesuit. So they are not going to go out to space craft, so they now have the spare hose. So what they did was that simple construction. It's a canisters with some cardboard, put the holes in it, a whole lot of duct tape, and then they connect up this canisters through the hose into the air exhaust intake of the lunar module. So instead of replacing the installations here in the circular hole, what they did was to tie it into air intake. So the air would first go through the square external canister before it even goes into the system. Right, so that was ingenious. So I'm sure you can look up internet. There will be plenty of people telling about all the great things that go into it and how it came into place, and end up with something interesting like this. Now, but for us, what I want to focus on is this. What can we learn from this Apollo 13 incident on how good engineers solve problems? Because we are engineers. We want to see what happened. In other words, I want to ask the question, how do we start with this square-shaped canisters? Well, we'll go through all the steps and end up to this actual construction from the Apollo 13 team. So these are all the real pictures. What happened behind the scene was that the 3 astronauts were not the one creating that connections. It was the ground crew in Houston. They actually have people looking at the problem. You have a whole team of engineers in the background looking at what is available and try to come up with the solutions. If you continue to read up the story, NASA actually has a backup lunar modules on Earth. So on Earth, they actually have the exact same equipment that the astronauts have in orbit. What they did was on Earth, they actually create the same constructions. They tested it on the lunar modules. They build prototype, and then they go through all the process. And then another ingenuity is that then they pass this whole design up through manual instructions. So there were no simple file upload like in internet at that time for space. So he was literally reading step-by-step instructions. You put the tape around it, you put a plastic bag, how long the tape should be, how stiff should it be, how do you put the hose, step-by-step going up. And that's what the astronauts were doing. These are real pictures from the Apollo 13 program. They were actually working on the hose, and you can see the canister floating in the back. And at the end, it ended up being a real device. It actually worked, and it helped them to have enough oxygen and lower the CO2 level for a safe trip back. So it's an excellent story, wonderful story, and they saved 3 lives. But what can we learn about good engineering? So just like I said earlier, if you ask different people about what engineering is about, you will get different answers. Similarly, if you ask even engineers, what make good engineers? How do you make good innovations? You will hear different answers by different people. If you ask me, that's what I will tell you. I'll tell you that you should think with the box. And that is something very funny, because you know what? I think most people might have heard of this. that you need to think outside the box in order to be innovative. And everyone on the internet will tell you that you have to think outside the box. If you are confined with the game that you cannot win, you just go beyond the box and then make an extra thought, and so you will win. That's what people would tell you. But if you ask me, I dare to challenge you that if you don't even know where the box is, how are you going to think outside the box? Right? So in fact, if you ask me, good engineering is all about knowing the box. It's about being able to go in and out of this box in whatever way that you want. What are these boxes? What makes them these boxes? Well, they may be just established practice. You have been building the same bridge for 30 years. In year 31, you are most likely going to build the same bridge the same way. You will have technical constraint or budget constraint. You have history and experience. You saw that people have been doing the same thing 100 years, use fire to make food. Then you probably want to do the same thing. Sometimes it's just artificial boundary. You say that, oh, I am just an electrical engineer. How am I going to deal with the mechanical parts? I'm a civil engineer. I don't know anything about computer. So sometimes these are just artificial boundary. Sometimes it's just conventional wisdom. There are a lot of things that make up of this box. But to me, I think it's extremely important for you to know your box and be able to go in and out of the box freely. So let's take the example of the Apollo 13 and see what happened. In the case of this Apollo 13, what are these technical constraints? Well, first of all, the CO2 level is already at a toxic level, so people are dying, so you cannot change that constraint. And then technically, they were in this lunar module. This lunar module was supposed to be landed on the moon to support the astronaut on moon. So it was designed to support 2 men, 2 astronauts for 1.5 days on moon. But now they need to use the lunar modules to fly back to Earth. That takes 4 days, and you have 3 astronauts. So we are clearly out of spec, but that is our technical constraint. That's our box. What are the boxes? Well, conventional wisdoms and established practice will tell you that, hey, you have a square canister. Maybe we should just cut it down, cut it to a smaller piece, stuff it into the circular hole. It will solve the problem. Or you go in and plug the hole out, enlarge it. Maybe that will solve the problem. That's your box. And then you have artificial boundary. Remember, the astronaut announced that in the lunar modules. The lunar modules was designed to go on moon surface. It was not meant to fly back to Earth. In fact, they were built by different contractors. So you now have different team of people managing different part of the space program, and all of a sudden you are telling them to change the goal. So you have now this artificial boundary. Who is responsible? Who is going to change how our lunar modules behave? Okay, so this is your box. And what happened at the end? What happened to this box? Well, for the technical constraints, there's no way out. People are dying. And the lunar module is already there. You are already in space. There's really nothing you can do to change it. So you definitely have to be inside the box. No matter how hard you want to go outside the box, you can't. How about this artificial boundary? So it turns out it's just artificials. At the end of the day, because you have men dying, what happened is that all hands are on deck. The moment they realize that they have to abort the missions and change the mission to a new one for bringing people back to Earth, that everybody is on board. You have the electrical engineer going in, trying to figure out the electrical system. You have the doctor, medical doctor coming in and look at the people, the 3 astronauts. You have the mechanical engineers coming in, looking at how the whole things may be breaking up and how to support the physical structure or re-entry. You have people in computer looking at all the way small things to navigation systems, because now it's broken. How are you going to navigate from moon to Earth? I don't know, right? So now you have everybody on hand. They even bring in the contractors to solve the problem. And you can see that if you read up the story, it's a truly multidisciplinary team. You have everybody from different expertise coming in together to solve the problem. And then we say history and experience is bad. Right? You have been doing, you are so old school, you are just going to do the same thing over and over, the same way. So turns out, no. In this case, experience really helped. Turns out, if you read up the story, it was Apollo 13 mission. In Apollo 10, that was 3-4 missions ago. They already have these crazy contingency simulations. And turns out, when they were doing all these random crazy simulations, one of the simulations turned out to be very similar to what happened to Apollo 13. It's not exactly the same, but they're similar enough that the people, the old men who were in the earlier program already have the experience and said, hey, it looks surprisingly like that crazy simulation that we said was too crazy. Turns out it was not crazy. Turns out we are in a very similar situation. We may actually be able to use the lunar modules as a space vehicle to come back to Earth. That's why they could come up with a very quick solutions out of these earlier experience. So experience definitely have a positive spin on this whole story. How about conventional wisdom? Conventional wisdom says that you have to change the way the canister is connected. It turns out, well, maybe we shouldn't be just modifying the way we connected, we put the two things together. Instead, maybe we are just going to reuse or repurpose what we have on hand. And that's truly out of the box. All right, no one would imagine using a food plastic bag and the cover of your space flight manual to make a makeshift constructions on board. So that's definitely brilliant. That's definitely out of the box thinking. So as you see, there's nothing too wrong about the box. And that, if you ask me, there's absolutely nothing wrong to be inside the box. But all of a sudden, you know that if you can go both in and out of the box, that's how good engineers solve problem. So by now, hopefully you have a slightly more insight into what engineers do. But some of you might be asking, hey, so you're talking about stories from the 70s. I was not even born in the 70s. It seems like all the problems have been solved already, right? So we have internet now. We don't have to deal with this slow upload. We can press one button and then you can do Facebook on ISS right now. Talk to the astronaut. SpaceX was trying to launch people to space yesterday night, but weather was too bad. So what's left for us to solve? The sad truth of this modern world is that we actually have a lot of problems. There's never short of problem to solve. And as an engineer, that means we have nothing short waiting for us to solve. So back in 2008, the National Academy of Engineering listed out 14 different areas as the global grand challenges of engineers. So they were just saying in the coming 10, 20 years, these will be the area that requires the most engineering talent. So we are just seeing some of the progress in some of the areas. So for example, make solar energy economical. So we are seeing more and more solar energy now. And secure cyberspace, we are still seeing that happening. Virtual reality, I think we are in the Hong Kong U case right now. We have a lot of virtual reality going on here. So a lot of them are going on, but they are still a long way to go. We are still a long way to go reverse engineering the brain, and we are still a long way to go preventing nuclear terror. In Hong Kong, we have this aging infrastructure, and then we are a long way to restore and improve our infrastructure. So what I'm just saying is that there are tons of problems waiting for us to solve, and you as a student will have a good chance to look at it when you get into engineering. So don't look down yourself. Just last year, I was actually bringing this whole team exactly to this Global Grand Challenge Summit, where they entered into a student competition and won. They won the business proposal first runner-up on this little robot that go into the water to collect plastic and help with the clean water problem. So finally, maybe you're very interested now. How can I become an engineer? So to me, you're in the right place. Having a good engineering education will be a very good step for you to become a good engineer. If you look at this diagram, going into a good engineering education gives you a lot of good educations in the foundation. You learn about math, you learn about science, you learn about the technology. But most importantly is you gain your experience. You'll have 4 years at Hong Kong, you're doing engineering, doing all the hands-on projects. That's where you gain your experience. That goes into your box. And one day you might be able to use this experience to help with your future endeavor. So with a good education, you can come in, build your box, build your whole experience, you work as team, and you will become a good engineer. So with that, I will start with just one quote from Gene. Gene was the lead flight director during that Apollo 13 when he saw that it was an explosion and it seems like people are dying. he yelled out this out of nowhere, let's solve the problem, but let's not make it any worse by guessing. So I guess that captured very well what a good engineer would do. And with that, I'll stop here and pass the time back to Kenneth. Thank you.
Oh, thank you, Hayden. That's now I'm even more convinced that I made the right choice as to being an engineer. Okay, so as Hayden mentioned, it's that we don't know, not only thinking out of the box. In fact, we have to think in and out of the box and think through the box. Okay, so at the same time, that's still a lot of problem. In fact, the problem getting bigger and bigger. In fact, sometimes just like what he showed is like a grand challenge. So as an engineer, we have to think big. And I hope that during the same time that you're convinced to also think about HKU Engineering. So I hope that next speaker, that's Professor Edmund Lam, that's our Associate Dean, Teaching and Learning, going to share with us that when you as an engineer are going to think big and think of us. Okay, let's pass the time to Edmund.
Thank you. So I hope you heard the keyword, that the world is full of problems, lots of them. And I hope you feel that you are part of this world and you are going to be part of the people who can help tackle some of these problems, who can put, using Dr. So's word, water to extinguish the fire. Now, some of these are positive. We want to make the world a better place. So these problems are actually good problems. By solving them, we want to make our lives better. We want to make our environment better. So my role for the next 10, 15 minutes is to convince you that to do that, HKU Engineering is a good place for you to be. So I hope you, as a prospective engineer, you will start looking at your choice for where to study in a very rational way. You want to think about data. You want to think about what information we have and make your choice accordingly. So why HKU Engineering? You can look up what happens, what are the background of this faculty, and you get some of these information. Then we have a long history. We are one of the founding faculties in the University of Hong Kong. So that means we are as old as the university itself, and the university is the oldest in Hong Kong. We are over 100 years by now. We have 5 departments spanning a very broad spectrum of different aspects of engineering. We have civil engineering, we have industrial and manufacturing systems engineering, we have mechanical engineering, we have electrical and electronic engineering, we have computer science. And together they offer a broad range of programs. You want to look at other data, looking at what are the profession in Hong Kong, where we call ourselves engineers, and you look at this thing called Hong Kong Institution of Engineers, our professional society, and you look up who are the greatest engineers that they have honored over the years, and you see that those in the Engineering Hall of Fame, we have 60, now 36, so you see names and all that. You get data like this, a ranking organization called QS, look at our various aspects, various disciplines in engineering, and gave us some ranking. And they are, maybe I should move over here so you can see, so they are pretty good. But you might also ask yourself, what does that mean, having these numbers? So having data is one thing. The next thing you want to do is to be able to analyze these data, to be able to interpret. So what happens with these numbers, right? Do you want to base your decision about where to study on these numbers alone? One thing I can almost guarantee you, I can't say too many other things, but I can almost guarantee you that over the next 4 or 5 years, these numbers will change, right? They might go up, they might go down, but they are very likely going to change. So will you base your decision solely on whether this number is 19 or 18 or 20 or 38 or 37 or 39, right? So I hope in addition to looking at data, you also think about how you want to interpret data. And the next level I want you to think about is what is really your objective of your study. And I argue that you have two, at least. One is to have a good experience at the university over the next 4 years. So we want to let you know what opportunities you might have within HKU Engineering. Another objective I hope you are thinking, although it's farther down the road, is life after getting your degree. So after getting your degree, maybe you go out to work and maybe you have, I don't know, 40 years of work ahead of you. Or maybe you only want to work 4 years and get rich and retire, right? So either way, you probably want to think afterwards, when you get a degree, what does that bring you, right? So with all these, I hope you now look at these with that perspective. So you look at HKU Engineering and you want to see behind those numbers, what are the faces, whom you are going to meet. These are some of the faculties you are going to meet. These are the people whom you get to know in person. Some of them did very good research and they get to be impressed. People talk about their work, right? And the question you might ask is, do I get to work with them? What happens? What does that mean if they get some prize, Innovators Under 35 from MIT? How does that relate to you? How does that affect your experience? And I want to say later on that you will benefit from these. The fact that we have world-class researchers means that you will benefit from working with them directly. In some cases, we have undergraduate research opportunities. You will also benefit from the linkage that they have. For example, these are some of the research labs due to our faculty that we have a joint lab with Harvard University. We have another research center with the University of Oxford. We are recognized as a very high-ranking faculty, and Tsinghua University and us developed a double degree on computer science. We also work with some other companies, and if you have been here when the dean made his opening, you also heard me talk about the Standard Chartered FinTech Academy. So these are continually going into the faculty, and these are some opportunities that will be available to you when you join the Faculty of Engineering. So you can see some pictures that we have. We also have, I mentioned the 5 different departments, but they also spend various new programs along the years. So some of these, particularly, I see that the newest one that we roll out is the Global Engineering and Business Program. I see that we are getting a lot of interest from the applicants, from your peers about this program where we want to nurture engineers with a global perspective and thinking not just with the technical side, but also with the business side. And hopefully, maybe some of you want to bring your technology, not just in the lab, but also to real world and make real impact. So at HKU Engineering, we are at the forefront of knowing what programs or what study would be most beneficial, and we bring in, we develop these programs. Right? So these are, a lot of them, interdisciplinary. You see things like financial technology, fintech, that also has business components, law components, and biomedical engineering, we work with the Faculty of Medicine. The Dean also mentioned about this innovation wing, and in fact, this is so important that our next speaker will actually talk a lot more about the innovation wing. So I won't say too much, other than saying that this is a very, very precious opportunity that you hardly can find anywhere else, where you get to have peers with like-minded passion to solve problems, to be hands-on, to tackle the challenges of the world, and have benefits along the way. Benefits could be financial because you bring these technology and people are using. The benefit can be the fact that you can see your idea being put to practice. Right? We have a lot of opportunities, so much so that we have a lot of different categories. One of them here is what we call the Dean's Club. You saw the Dean, but unfortunately, you all being in the virtual world would not get to really greet and talk to him yet. But if you come to engineering, you might get to be a member of this Dean's Club, and he will personally mentor you. Now, our Dean he is an alumni himself from this faculty, and he has a lot of experience, a lot of contacts with the industry, and by being his mentee, you get exposed to lots of different opportunities around here. And not just around here. I talk about the undergraduate research program. That is not only, of course, you could be interested in working on research with faculty members within Hong Kong U, but because of the relationships, we often also link the students to other universities. So you can be working with faculty members at other universities. These are just some of them. I won't say too much about each of them. You have, again, other opportunities that we have mentioned. We have some selected stories. This is one student in our faculty. She is in the computer science department, and she had a profile in the newspaper about why she picked engineering and her passion to study artificial intelligence, and how that in her view she wants to use that to solve problems and help mankind. So you can also look at some of the things that she has done, scholarships that she has obtained, and also exchange opportunities that she had. I said at the very beginning that one piece of data you would know is that Hong Kong U Engineering is the oldest in the city. Now, one implication of that is that we have the strongest alumni base in Hong Kong, definitely, but also worldwide. We have alumni working worldwide, right? You get to identify with them, and they get to, of course, I'm not saying that they would necessarily show favor to you, but chances are, being from the same school, having the same experience, you can bond with them a lot more easily, right? So our graduate statistics have been good over the years, right? And we also see a lot of interest from our students and also our young alumni starting their own companies. And we have a few pictures here, some of them receiving awards and all that. And for starting your companies, having a good connection to the industry, knowing how to get funded, knowing where to find markets, those are even more important. And having a strong alumni base will be tremendously helpful. We have, as I said, we have been rooted in Hong Kong, but we have students coming from all over the world, and we have alumni at in various parts of the world. And we also have partnerships. We have one of the largest partnerships with various universities worldwide. You can go on exchanges at almost every continent and lots of different countries, lots of different universities. Right? I know you probably can't see it because we just have too many and we just put too many names over there. So I'll say the last thing I want to say is about accreditation. You hear a lot when we talk about engineering, we say this is a professional degree. And what that means is our degrees are accredited. And you probably might ask, well, so what does that really mean? That means if you want to be a chartered engineer, you could. And it's not just in Hong Kong, because the accreditation, being part of this thing called Washington Accord, means that you have, if you someday want to work in another country that are also part of this Washington Accord, and that means a lot of countries, then you get to be a chartered engineer or equivalent in those places, in those countries as well. So your job prospect is not just in Hong Kong. You are recognized at different parts of the world. So I hope when you think about what to study, you look at these data, you look at your objectives, not just your 4 years, but also your future career, and make a rational choice. Right? And I hope to see many of you, hopefully in person, get to greet you in August and September when you start school. Thank you.
Okay. Oh, thank you, Edmund. So I think that's the only thing the impression I had, I just born a little bit too early, 20 years early. That's, otherwise I miss, well, anyway, I hope that you guys all have the opportunity. So without further ado, as Edmund already mentioned it, so we were specifically very excited of the upcoming opportunity. It's related to our innovations initiative. So now we're going to pass the time to our another associate dean, Professor Thomas Ng, talking about our this latest activity. So thank you.
Thank you. Well, after listening to the presentation of Dr. So and Professor Lam, I'm sure that majority of you, if not all, have already made up your mind to do engineering. But I believe the next question is, which institution in Hong Kong, which university to choose? Well, if you want to live an easy life, don't come to Hong Kong U, because we'll make you very, very busy. Okay? So at Hong Kong U, we pursue 3 things. One is active learning. Okay? The other is creative thinking. The other is problem solving. Okay? Now, so seeing the opportunity, well, the engineering faculty has put a lot of investment into the new innovation wing, which I'm going to introduce. So the dean has already mentioned that the innovation wing is one of the biggest in Asia, if not in the world. It's got 2,000 square meters in terms of floor area. And it's got a lot of innovative equipment embedded in the innovation wing as well. So at the innovation wing, we pursue interdisciplinary research. So you're not just studying a particular discipline, but instead we welcome you to join with some other fellow students within the faculty or even outside the faculty to invent something in the end. Okay? Now, so hopefully, this place will give you some all right, okay, some grand initiative for you to think about. At Hong Kong U, we pursue a few things. We would like to train you to become a responsible person. So being a responsible person is extremely important in engineering, because when we think about you are going to design a car, design a building later on, it's not just about you, right? It's all about the users of these cars, this building. We also like you to be an entrepreneur. Some of you would have a lot of invention. So later on, you'd like to establish your startup, and we would like you aware of the development around the world. So more recently, the coronavirus has given us a lot of opportunities or challenges, right? So these challenges are not just related to medical doctors, but they are also related to engineers. We would also like you to become a leader in the world. So with all these, we would like you to become a real engineer after you finish studying in the Faculty of Engineering at Hong Kong U. So at the Innovation Wing, we have several initiatives. One is to bring activities for you. So there will be a lot of activities being organized by the faculty. There will also be activities being self-initiated, okay, by students. If you have some grand ideas, there's no harm in forming some teams. Talk to the director of Innovation Wing, and I'm sure that it will facilitate you to make these activities to become true. Well, we want to make use of Innovation Wing to connect people together. So it's not just about teaching, right? But more importantly, just hang around, have a cup of coffee, talk to people. I think this will generate new ideas. Well, we've got the facility, obviously, right? Last but not least, we've got the knowledge, because at the end of the day, we will invite the leaders in Hong Kong, in the world, to give you some innovative ideas about engineering, so that you can open your eyes, open your minds, and so on, to think outside or inside the box. Now, the design goal of the Innovation Wing is transparency, openness, right? So you can see at the front of the Innovation Wing a lot of glass walls and so on, such that your creation, your invention can be displayed to the outside world. Some of your activities will also be revealed to the outside world as well, while you're working on that. So I can take you through the Innovation Wing. We have the makerspace. So we have the machine workshop. We have the electronic workbench. So laser cutting machine, 3D printing, etc., etc. So the whole idea is to make all those facilities available to you, so that you can build the prototypes at the end of the day. We also have a lot of digital facilities, so including the AR, VR facilities, wet lab, and so on. And not to mention about some of the computing facilities to allow you to do design, to do CAD, CAM, etc., etc. As I mentioned, it's a place for sharing, for communication. So in the Innovation Wing, well, we have an area in which you can share ideas. You can also have some places for discussion, brainstorming, with your fellow engineering classmates, or someone outside engineering as well. Okay, so we've got the wall of achievement, so that you can put what you have invented, created, in the Innovation Wing, and showcase to the fellow students, or even showcase to the outside world. We've got a very nice bell, so that once you have successfully created a new invention, ring the bell, and to tell people you are successful. Okay, and not to mention about the multimedia wall as well. And we do have a lot of new initiatives, including the robotic initiatives. This is one of the very strong areas in which Hong Kong U Engineering is working on. So all types of robots, including the robotic arm, AVG, UAV robots, and also some of the robots which can be applied to the logistic, etc. So those are more industrial based. Well, we also have teaching facilities. Okay, I shouldn't forget about the importance of teaching. Although we'll keep you busy working on something else, but teaching is the foundation, as Dr. So has mentioned about. So we'll make use of some of the space for the teaching purpose. So you can see the space is very large, and basically we can have large group teaching activities. Well, we can also have some facilities for the UAV, VR type of events as well. Okay, and well, we have initially come up with several different initiatives to start with. Now, but this is just a starting point, right? So I'm sure that with your participation after you've joined Hong Kong U Engineering, you can go beyond the boundary. So these boundaries, these 6 areas that we're focusing on include the smart technology for better living. We also got the AI and robotic that I've just introduced. We've got advanced new materials. We've got green technology and sustainability, which is a very hot area. We've got healthcare technology, which is extremely important in future, especially when we are facing an aging population. And not to mention about the importance of e-learning as well. So what do we provide in a way? So we provide funding. Funding is important, right? Through Dean support, the Dean will support some of the initiatives created by the students. And we provide a workspace, which is also equally important, brainstorming area, equipment, etc., etc. Those are the hardware, those are the resources that we're going to provide through the innovation wing. But I think the most important is not the hardware. It's not about the facility. To make the innovation wing work, students are at the core, right? And so that's why if you want to come to Hong Kong U, you will become very, very busy. We will make you very, very busy, right? Now you can interact with the supervisor. There will be different teams, and those teams will be led by different supervisors, right? There will be advisors as well. And those advisors could be students, could be PhD researchers. They will take you through some of the ideas and inspire you so that you can think even further. And we will also have the technical support as well. Now, currently at Hong Kong U Engineering, we have already created a lot of different teams. Some, as I mentioned, are related to robotics, for example, Global Master, GlobalCon, and so on. Some are more related to the real projects, for example, Project Minger, and electrical vehicle racing team, machine learning society, design build flight team, etc., etc. So some of those teams, if not all, will have their activities at the inner wing. And well, you are more than welcome to join all of those teams, if not all, at least 1 or 2 of those teams, and start innovating when you join Hong Kong U. To give you some example, we joined some of the international competition. This is the Global Master robotic competition. We participated in that basically. And if you like car racing, don't just sit in front of the computer to do the car racing. Come and join the Hong Kong U racing team, okay? Because they build racing car for the Formula E, all right? Very important. And if you would like to, join the aviation industry, we've also got initiatives related to aerial technology. We won, the Fly Your Idea, the Airbus competition back in 2017. All right. If you would like to do civil engineering, you may want to apply your knowledge in some of the real-world projects to relieve the poverty and to help those underprivileged children around the world by building those facilities physically. There are a lot of different activities, so I don't want to go through them one by one. But once you join Hong Kong U, you've got to explore all those activities yourself, okay? Not just me telling you. Okay? So what's the ladder towards this journey? First, being an explorer. Okay, so you explore different initiative first. Try to hang around, talk to people, see whether you're interested or not, then contribute. Okay, so no matter how small the pot is, just pay a little bit of effort, and then in the end, we really want you to become a leader of those initiatives, and start further kind of flourishing those initiatives. So there will be an engineering annual show. Well, there was one last year. Unfortunately, because of the pandemic, we couldn't have another one this year. But the annual show is a place, is a venue in which students can showcase their innovation. All right. So this annual show will not be possible without your participation. Okay. So please, when you come to Hong Kong, you join those show in the end. So I'd like to reiterate: responsible, being a responsible engineer, become an entrepreneur. Aware of what's going on, in the world, and try to think out of a solution, an engineering solution, in order to help solve the problem, and become a leader, which is our ultimate goal. I can tell you, a lot of our alumni are assuming very, very top positions around the world, not just in the academic field, but in the government, in the big corporation. So I'm quite sure that, choosing Hong Kong U will not put you in the wrong choice, okay? So without further ado, I'll pass on back to Kenneth. I know there will be Q&A session afterward. Thank you.